this is the juncture now that we're starting to see formulas, where I want to go over the different formulas we might see and give you kind of a heads up. We already said that this formula, and this formula are the only three that are out, and this one as well. It's not really critical to this. This one is actually is really kind of incorrect, and you'll come to see why. But these are basic formulas. These are those that are put forth by the College Board for the AP exam. Now, of course, we see here is the P equals MV. We know the change in anything is equal to the final minus the initial, so we don't really need a formula for that. Now, if P is MV, then a change in momentum will also be due to a change in the mass, the velocity, or a combination of the two. So I've put this in red because this is the one that we most often see. We will see some examples where that's not the case, but really the AP is going to ask you questions. I can almost guarantee that it'll only be about delta P equals M delta V. So you can think of it this way, but I want you to know it's broader than that. It could also be due to a change in mass with constant velocity. It could be due to a change in mass and a change in velocity, which is the case of a rocket, it turns out. So that being said, we know our definition for momentum. This is unnecessary to even think of as a normal formula. This also, of course, a change in something is due to change in one of the variables. We don't need to even have this one as a separate one. This one, however, is an important definition. Now, you'll notice it looks like this one over here. It's just rearranged, but this is the actual definition of force. That's the definition of force, the rate of change in momentum. This is just a formula, a rearrangement. There's nothing special about this, but this is the definition. So I'll say that's very important. This one is also very important, and it turns out, for reasons we'll see later, that these two are equal to each other. And that is what this is. You'll say J equals F net delta T equals delta P equals M delta V. And then there's this one which doesn't appear at all. And you'll come to see this one's so easy we don't really need to memorize that. This last one is the definition of kinetic energy. So all being told, what we are left with is this is the formula you definitely need to know. This is one you definitely need to know. This is definitely one you need to know, which is not included. This is one you definitely need to know, and this is definitely the one you need to know. So that gives us 1, 2, 3, 4, 5. And this one is given. This one is given. The two that are not given, this one and this one. And it turns out this is the number one most useful formula in this whole unit, and it's not given in any shape or form. And this is probably the second most useful. Now, these others are formulas we're going to see. You know enough to see that, let's see, well, P equals MV, and we know V equals AT plus V0. Oh, so what did I do? I just substituted that in there. That's not worth your time. These two formulas are substituting this into this to give you two other versions. So there's no reason to give those special attention. And the others are kind of common sense formula play around. All right, so at this point, you should be thinking about committing to memory this one, this one, this one, and this one, with the two that are red squares being the ones you really need to memorize because they're not given in any way, shape, or form on the formula sheet.